Okay, the guppy tank that I knew from childhood through pretty much through middle age. Okay? Yep. House is known with friends of my parents. Okay, I counted them. Starting when I was 5, I counted them every day. And the population was always 1,000 plus or minus 2. I'm sure of that. Okay, well, no. But we'll assume a carrying capacity of 1,000. And when I visualize that tank, 1,000 guppies seems maybe a little high, but maybe not. Okay? A lot of guppies in that tank, it's dense. So you have, let's say you have a new tank with 10 guppies, and you find that that tank doubles to 20 in 7 days. Okay? So my question is, the population is a function of T. Okay? Well, we could go to the general solution of a logistic equation and plug in some numbers. We know L, but we don't know K. Right? But we know Y at, let's say, time T equals 0 is 10. So we can solve for K, right? So just take this equation and solve for K. Okay, well, let's go ahead and do that rather than running through the entire solution. Okay? But I'm not going to let you get away with that. I don't want you to memorize this and just use it. That's not even calculus, that's algebra. Okay? It doesn't teach you anything about how to solve a differential equation. That's the result of solving a differential equation. It's just like the Bernoulli equation, okay? M equals 1 minus n. There's no magic to that. Of course, then you do transform it to a differential equation, so there is some differential equations there. There's no dang differential equation in this at all, okay? So I have no respect for this. Now, by no respect, that means if it's a 10-point problem, that's all you do, you might get 2 or 3 points, okay? Which isn't even passing, but it can't hurt if you don't remember how to do the rest of it, okay? And I'm generous with 2 or 3 points. Had an outstanding school. I think that'd be a 0, okay? We want to be good. If we try to be outstanding, nobody's going to pass. But you're still going to get, you don't want 2 or 3 points on a problem, right? Okay? It's not much better than 0. So, I try to be about 10% less demanding than they do. Okay. And how that translates into 10%, I don't know, you figure it out. Solve the right differential equation, you can see that 2 or 3 points is about a 10% transition standard. Okay? Okay, so you got this. Okay. Now, of course, it's now P and not Y. Okay, assuming P is 10 when Y is 0. When T is 0. L equals 1,000. You have 10 equals L times A over A plus E to the negative KLT. I said we can solve this for K, but A is also an arbitrary constant. Okay? And that should be negative KL times 0, not negative KLT, right? Okay. Well, we also have the information that after 7 days the population is 20. And now we have two simultaneous equations in A and K, right? However, one of them is really easy to solve. Okay? Negative KL times 0 is 1, right? So you can actually solve this equation for A. You don't need to solve it as a system of simultaneous equations. Well, you do, but this one's immediately solvable for A. You don't have to do anything, okay? And once you have A, you put it in here, and then you can solve for K. So this implies so A equals what? I'm using L here, but it's 1,000, right?
Yes.
And 10 over 1,000 is 0.01. So A over A plus 1 equals 0.01. So 0.99A has to equal 0.01. So A is 0.01 over 0.99. So A should be like 0.0101. If I did that right in my head, let's check it out. 0.0101 over 1.0101, which is about 0.01, should equal 10 over L, which is 10 over 0.01, right? So unless I screwed this up, and I don't think I did, you would get A equals 0.0101, okay? So you get 20 equals, I said equals, and I wrote a parenthesis. Reading a lot about the brain and perception. So it gives me something to think about, okay? There's something with perception going on here. And L is 1,000, so that would be 7,000 e to the 7,000, negative 7,000 K, okay? Now, if you multiply this by 0.0101, you get 1,010. 20 over 1,010 is like 0.02, that'd be 20 over 1,000. But you take 1% off of that, okay? And you get, now I'm losing track of what I just said, not perception, something else. It used to be there, but it is. So again, 10% less than 0.02, which would be 0.0198. So we get this. it's 0.0198, pretty sure. But let's just write this as a reciprocal of what you get here. It's going to be $1,010 over 20. Okay. Then you divide by 0.0101 and you get, well, you subtract that, but it doesn't make any difference. E to the negative 7,000 K is about this. Okay? And then you take natural log of both sides and you get a result. And I'm not going to try to estimate it. Okay? I will say that the K you get here, since this population is way less than the carrying capacity, is going to be pretty close to what you do if you just did exponential growth. Okay? And I might well ask you to show that as part of your homework. Okay? And I'll say this is close. What you get if you assume exponential growth. That is exponential growth. Hard to read that. Okay? So I might draw that out in your homework. Okay, well, that's great. Now let's solve the equation by writing a differential equation for the situation, right? Okay? So, we get now, just a side comment. As an engineer, this is probably what you'd end up doing. But if you want to understand what happens if there's little tweaks to the system, you better know how to go back to the differential equation and solve it. Because solving the differential equation is very simple. You can just do partial fractions, okay? And anybody who can get an engineering degree can review partial fractions and do it easily, okay? But what we're learning here is not how to use the result of solving a differential equation, but write the equation so that when there are slight changes in the conditions, we can modify the equation and hopefully solve it, okay? So we're going to write and solve the differential equation. Okay, so, well, let's see. We're going to say, okay, assume that the growth rate essentially what we're doing. We're assuming that the rate of change of P is proportional to both P and the proximity of P to the limiting population 1,000. Now we're also assuming that these are linear proportions. And by proximity of P to the limiting population, we mean limiting population minus P. Not the square of the limiting population minus P, which we could do. Okay, if it was a square of the limiting population minus P for some reason, can't imagine what the reason might be, but if it was, you see, as an engineer who depends only on this solution and forgets what you're doing, you're lost if it happens to be that, or some power other than the first power, right? But if not, the techniques still apply if it's some power of L minus P, okay? Okay, well, so you need to be able to get through the process. Okay, well then, P prime is proportional to P times L minus P. And if you're not really conversant with proportionality, get that way. You need it again and again. You don't understand things unless you understand proportionality. And I started struggling with it at the age of 12 in 8th grade. Maybe I was 30. I turned 13 shortly after beginning of 8th grade. So, had a teacher there who was a math fanatic. That was a very nice lady. And her family owned a candy shop. So she was just, she was great. She was great. Not sure how much mathematics she knew, but mathematics was her hobby. Okay? Yeah, I did fine in math up to that point. That's what really got me interested. And proportionality is one of the biggest things I learned that year. Okay? I didn't learn things like proportionality to the square, proportionality to the cube, but I learned about proportionality and inverse proportionality and the techniques used. So when we got to proportionality to squares and proportionality to inverse cubes and whatever, it was an easy adaptation, and I could think about what it meant. Okay? Nobody can even spell proportionality. It comes out of our schools these days. So, things were great in the good old days. Well, yeah, there's some downsides also. So, but I keep coming back to that because that's pretty much the education I got was pretty good compared to what people get now. Kind of, space race and all that stuff. More emphasis on STEM at that time than there is even now, even though people have an abbreviation for it. Okay? The rest of the world's getting something even better than what I have. I keep coming back to that. So you need to understand these things. And I keep pointing out deficiencies that I observe again and again that shouldn't be there. So you want to try to remedy them. You want to try to make those. Okay, so anyhow, P, it's proportional P minus L minus P, meaning there exists a constant K such that Y prime equals K P times L minus P. Right? Equals, now K, we don't know, okay? P, we don't know, but L's 1,000. So what? And it's no P prime, not Y prime. Yeah, one thing they didn't teach us was to keep our symbols straight. Now I knew how to do that too at one time. That part escapes. So I got to be careful. The rest of it's pretty much still with me, as long as I don't try to do anything too far over my head. Okay? Okay, so we have this. So that means P over P times 1,000 minus P equals K. dt, that's dt. And that's a more or less instant transformation. Okay? So, well, we do the partial fractions, okay? And I'm not going to go through that. But it tells you that the integral of 500 over P plus 500 over L minus P dP equals KT plus C. So that 500 times the natural log of the absolute value of P minus natural log of the absolute value of L minus P, and L's 1,000, so I should write that. 1,000 minus P. Equals KT plus C, so that 500 times the natural log of the absolute value of P over 1,000 minus P equals KT plus C, so that P over 1,000 minus P. Don't skip steps. And think about what the steps mean. See, some of these steps have any meaning in terms of those guppies, other than these are the algebra steps you go through to get that equation that we can then solve for A and K, right? Well, you get P over 1,000 minus P equals A e to the K over 500 T. Okay? Now there's steps to fill in. It's not automatic. But you divide both sides by 500, you get the K over 500, the C absorbs the 500, and all that stuff, so you get the A. And now we specify A not equal to 0. Okay? For reasons that you should totally understand by the time you're done with this, if you don't already. Okay? So we have this, right? And then it's good to go through these steps because they're easy to lose track of. And then you're going to have P times 1 plus A e to the K over 500 T. Not writing that very well. Put the E down there a little lower. Now it looks like a subscript, so I'll make the A longer. Okay, there we go. Okay. Equals 1,000 A e to the K over 500 T. So that P equals 1,000, which is the carrying capacity, multiplied by A e to the K over 500 times T, divided by 1 plus A plus e to the K over 500 times T, which could also be written, your preference, but you only have one exponential if you divide through by the e to the K. So it's simply this way. A over one plus A e to the negative K over 500 times T. Okay? And that negative's got it stretched in there. Okay? So now you have this specific situation. We're officially out of time. You guys usually stick around for a few minutes. I guess you got no place to go. So I'll take 2-3 minutes. Okay? The rest you got to do. Okay, but just to remind you of what has to happen now. Well, now we know that P of 0 equals 10, and P of 7 equals 20. Okay? Now, you know, that's pretty close to the doubling time. Okay? And the doubling time is the time it takes the exponent to increase by factor square root 2.71. Okay? Or 2. Okay, e to the 0.71 is about 2. Okay? So 0.71 times your doubling time should be about 7 days. So your doubling time should be a little less than 10 days. Okay? And your K should be accordingly. Okay? And you can kind of use that insight if you've got it, which you hopefully either do or can develop. Okay? Based on what you learn in calculus. And compare the K you get, just what K does it take to give you a doubling time of 7 days? Okay? Or what exponent does it take to give you a doubling time of 7 days? Okay? And that should be close to the exponent you get here, negative K over 500. Okay? Not exactly the same. So then you plug this in the way that we already did, using the general solution to the equation as a formula, and you can see the similarity. At least if you review a little bit, you can see the similarity between the general equation we got the first time we saw the symbols in this equation, right? And it should then confirm what we got just using that thing as a formula, ignoring the fact that they're differential equations involved. Okay? And again, what would it be if, it wouldn't be, but what if this was squared? 1,000 minus p. Well, then your partial fractions would look a little different. Okay? That's all. Okay? And you'd have 3 terms. You'd have a quadratic term, and that would complicate things because it wouldn't any longer be just an exponential, a thing with exponentials, a thing with natural logs and exponentials. And that'd be impossible to put it in closed form, but you'd still have an expression you could work with. Okay? And as an engineer, you wouldn't want to do that specific thing here, but that illustrates the fact that if you change the conditions just slightly, things change, and you should be able to compare what happens. Let's say that instead of an exponent of 1, it was 1.01. Okay? Your solutions should be pretty close to this one, but they're not going to look the same. Can you compare those functions? Well, it's just algebra and pre-calculus, but it's fairly challenging. Not every engineer would be able to do that. I'd say most wouldn't. Research engineers, sure. Okay, engineers that followed a strong mathematical path, did the advanced engineering mathematics, whatever they call it, at whatever school, and then even did some graduate level mathematics, would have the sophistication to deal with that sort of thing. Now, an engineer
So you could get a fish.
whose IQ is out there and had just had the 4 semesters of calculus would be able to do it too. Okay, somebody's IQ isn't out there with just a 4 semester of calculus, probably have trouble with it, unless somebody showed them. Then they probably understand it. Okay, so you can judge just how powerful it's reasonable to try to be. Can you answer questions of that nature? But I'm not going to test you on it. Okay, it's a little beyond the scope of what we do. Okay, so work this out. Okay, it's straightforward until you start throwing. And we do throw some stuff at you. We'll throw some stuff at you. I'm going to give you some basic questions because Thursday's only 2 days away. And then next week, I'll be asking you some more advanced questions. Okay?